This is the first lesson in the indices and surds topic. In this lesson, we'll look at simplifying rational numbers. So we'll start by looking at classifying and basically telling the difference between rational and irrational numbers. And then we'll look at how we simplify rational numbers. So we'll look at terminating decimals, and then we'll look at reoccurring decimals as well. Okay, so when we consider rational and irrational, there are some defining features. So any rational number can be simplified into a fraction using whole numbers, or probably better to say integers. So an integer is just any whole number between negative infinity and positive infinity. So for example, anything that can be put into the form a on b. So that's what a rational number is. Now they can consist of a few different things, and we'll talk about them in a minute. Irrational values, they'll have infinite decimal places, and there's no pattern. They cannot be shown as a over b used in integers. So rational, irrational. Today we're talking about rational, and then we'll spend the rest of the topic working with irrational values, or surds. Now if we broke both of these down, so they both fit into what we call the real number system. And the real number system is obviously real numbers, generally the numbers that we work in. If you go on to do Math C, you'll learn about complex numbers, which start to include imaginary numbers, and we're not going to go into that today. So the real number system consists of rational and irrational. Now, rational can be broken down into a few things. It can be integers or decimals. Now, the decimals that fit into here are terminating or reoccurring. So there has to be some kind of pattern. Terminating are pretty straightforward. They just come to a stop, so it might have 3 or 4 decimal places without rounding. So something like this, 0.32 would be terminating decimal. 0.1743 would also be terminating. Now, reoccurring just means that there's some pattern that's reoccurring over and over again. So we normally represent it like this. 3.72 with a line over the top means that that 72 is repeated over and over again. So 3.727272 and so on. Or 0.5 reoccurring like that. All of these can be manipulated to put into a fraction form or a ratio form, a over b. Now irrational breaks into 2 parts as well. So the first side is surds, and surds is anything inside a radical or a root that cannot be simplified down. So let's say we've got square root of 5. If we put that into our calculator, it will give us a decimal answer. Now those decimals don't have a pattern like the reoccurring. They just keep on going. Square root of 5, cube root of 15, square root of 72. Any of these types of things are called surds. The other one, transcendental, and they're ultimately irrational constants. Now, one of them you know really well, pi. There's lots of them as well. There's Euler's number, and a whole list which we don't really need to worry about. But they're anything that's been calculated, mathematical constants have been calculated so many decimal places. There doesn't seem to be a pattern, and we use them in certain mathematical formulas or proofs. So there we have it, that's a real number system. So now we're going to look at working with terminating and reoccurring decimals to put them into their simplest form. Okay, so we look at these 3 values, 0.32, 1.752, and 6.05. The idea is to put them into a fraction form using only integers. So we can start by considering 0.32 and looking at it as 0.32 on 1. So we've already turned it into a fraction. Now the next step is we need to get rid of those decimal points. So we know if we multiply 0.32 by 100, it becomes 32. And if we do that on both top and bottom, then what we end up with is a whole number or an integer on top and bottom. Now the only thing that's left to do is to simplify that down. Now I know you can use your calculators, but it's good to use your brains as well. So we're thinking about what can we divide each of these numbers by to simplify them. So both of them immediately you can see they're divisible by 4. So 32 divided by 4 is 8, and 100 divided by 4 is 25. 25 is only divisible by 5 and 8 is not, so that's our simplified answer, 0.32 2 is equal to 8 on 25. Now when we look at our second example and we consider 1.752 and we think about it as 1.752 on 1, and this time, because there's 3 decimal places, we're going to have to multiply by 1,000 on top and bottom. So we get 1,752,000. Now these values are a bit trickier to work with. We start by dividing by something we definitely know that we're going to divide by, and that is 2. And that gives us 876 on 500. Now, I would say that both of these are divisible by 4, or you could do 2 again if you wanted to. So we end up with 219 over 125. So there we have it. 1.752 is equal to 219 on 125. Now last example, 6.05. Again, we write it 6.05 on 1, and we multiply by 100. 2 decimal places there. So we get 605 on 100. Now we know straight away each of these is divisible by 5. So we get 121 on 20. And as these have no common factors, they won't simplify down anymore. So 6.05 is equal to 121 on 20. So there we have it. That's converting terminating decimals into simplest form. Now when we look at recurring decimal, when we're looking at working with recurring decimals, we need to think a little bit further. So a little bit of algebra is involved. Now the first thing we always do is we let x equal whatever that original problem is. So x is equal to 0.3. Now our goal is to manipulate it so we no longer have any decimals. And when we can do that, we can just rearrange to isolate for x. So if x is 0.3 reoccurring, then 10x will be 3.3 reoccurring. So we just multiply by 10. Now this is where the trick comes in. We can see that if we take 10x and we take away x, and what we get is a whole number or an integer, because we cancel out these recurring values. So we end up with 3 here, and 10x take x is simply 9x. So here we've got 9x is equal to 3, and if we rearrange that, we get x is equal to 3 on 9, or x is equal to 1/3. So there we have it. 0.3 reoccurring is 1/3. Now we can take the same approach then with b. We can let 1.37 reoccurring equal x, or x equal 1.37 reoccurring, and we can manipulate it in the same way. So if we look at not 10x this time, but 100x, then we get 137.37, and therefore if we take 100x and subtract x, then we're doing the same thing. We're cancelling out those recurring decimals. So we're left with 137, take away 136, and 99x. Then it's just a matter of rearranging, and we end up with x is equal to 136 on 99, and that won't simplify down any further. So that is our simplest form. So now we'll look at the last example, and this one's a bit of a tricky one. So we can let x equal 0.5263, and so all those 3 values are repeating. Now we'll have to consider a few different things, because it's not going to work unless we just have that 263 repeating. So if we multiply this by 10, we get that 10x, we get 5.263 recurring. Now if we multiply this 10x by 1,000, so it becomes 10,000x, then we've got 5263.263 recurring. And if we take 10,000x and subtract 10x, then we've achieved our goal, which has been the same goal for all of the other problems. So we get 5263.263, and we're subtracting 5.263. So the decimals cancel, and we've achieved our goal, and we're left with 9,990x, and 5263 take away 5, which gives us 5258, and then it's just a matter of isolating x. So we get 5258 on 9990. And if we use our calculator to simplify that, simplified answer would be 2629 on 4995. Now we have it our simplest form. So that concludes the first lesson. A little bit of classification and some problems involving simplifying. Working with fractions is good practice, particularly if you go into Maths C, and even in Maths B we tend to like to leave things in exact form. So being able to convert things into their fraction form is always beneficial.